Good morning, everyone. So, the topic that I will be discussing today is about ideal gas. So, when we say ideal gas, it is one which PV over T constant under all circumstances. So, before we go to the ideal gas equation, what is STP? So, STP is the standard temperature and pressure. So, under pressure, STP this equals to 1 atm or 101.325 kilopascal or 14.7 psi or so on. And then under temperature, it is equal to 273 kelvins, and volume, it is equal to 22.4 liters, and in mole, it is equals to 1 mole. So I have three derived ideal gas equations. The first one is PV-nRT or paborito niya, where the P here is the absolute pressure. When we say absolute pressure, it is the sum of the atmospheric pressure and the gauge pressure. Okay, so the V is the volume, N is the number of moles, or it is equal to small letter m over m, or the mass over the molecular weight. So here is the units in SI and English units. So R here is the universal gas constant, and T is the absolute temperature. So when you say absolute temperature, this is in Kelvin or Rankine. The second one is the PV equals MRT or pavo rito mo, wherein P is the same with the first equation, V is also the volume, M is the mass, R is the ideal gas constant, wherein it is equal to universal gas constant over the molecular weight. And then the T here is also the absolute temperature. So here is the proof why this is just the same with the first equation. So PV and RT. So here, so N is equals to M over M, or mass over molecular weight. So copy here. So this is so if we're going to rewrite, PV is equals to M, so R over M, M is T. So let R is equals to R over M. I mean, small letter r equals to big letter R over M, or the universal gas constant over the molecular weight. So PV is equals to MRT. So they are just the same. So the last derived equation is the mass density is equals to P over RT, wherein P is the mass density, or is also equal to mass over volume. So proof. So here is the proof. So let us